Hi everyone. Today we will discuss about heap data structure. Actually, it's just a representation that we can build in arrays data structure, or we can build with using Java library functions like priority queue. Those heap data structure actually it's used for we can use it for sorting purpose. And in this video, we will discuss finding kth maximum element that we will discuss at the end. So other than the selection sort, insertions on bubble sorts, the time complexity is very less in heap sort. So let's start discussing how to build it. So let's let's take first an array. I will take elements here, uh, 10, 20, 40, 30, 80, 60, 50. This is a given array, ARR, given elements, 0 index, 1 index, 2, 3, 4, 5, 6. So size is 7. So now how we built heap data structure is, we will follow like this. We will build in a form like uh, it will looks like a tree, like this. In the here in heap, we need to understand the two things. There will be min heap, there will be max heap. Min heap means the parent value always less than the child value, and max heap means whatever the element here, the parent value will always have the greater high value. That is, suppose it's 50, then it is 20, 30, like that. If it suppose it is 15, then 15 should be less than these values, 20, 25, like that. So this is about mini heap, max heap. We can construct any one. We will discuss now how to construct max heap. So first I will take here this value, 0 index, and I will take the 0 index as a root. And now for the uh, next, to find left child and right child of the 0, we will follow one notation, that is 2 into I plus 1. And for the right, we will take 2 into I plus 2. So or we can say this as that left plus 1. So 2 into 0 plus 1, that is 1 index. So the for 0, the left child is 20, and for 0 the right child is left plus 1, that is it is 2. The 2 we have the element 20. Then for 1, 2, 2 into 1, 2 plus 1, 3. So 3 we have 30, and then it is left plus 1, that is 4. We have in the 4 we have 80. Then next 2, 2 into 1, that is 2, 2 to 4, 4 plus 1, 5. So 5 we have 60, and 6 we have uh, 50. Now I will write the logic here. Okay. So first I will start with the code heapify. So in heapify, we will uh, before the heapify we'll do the build heap. So build heap, we will pass that array, and size actually it is 7, right? We will pass the last most index 6, that is suppose 7 minus 1, like. Now I will check here in the build heap. I will check here I equals to size by 2, that is 6 by 2 3. I will take 3. Then, like, I will take the leftmost bottom node first. I will start build heap for it. Then here, uh, then I will take from I equals to size by 2, that is I equals to 3 to I is greater than or equals to 0, I minus minus, that is I will take for I equals to 2, and 2 3 2 1 0 everything. So I will simply do here heapify. In the heapify, we will take that array, then whatever that I, and size as 6. So that I will write the code here. So for heapify, I will take that array, and whatever that index, and size. So now I will start do uh, constructing heapifying. That is, we will check whether it's a max heap or a mini heap. So I will simply first take that left into left is 2 into index plus 1, and right is uh, left plus 1. Then I will take max equals to index. So to find, actually, in the max heap the parent value should be higher, right? So since we are building here max heap, the parent value should be higher, right? So that one we will adjust here. So I will take max index. Then I will just check in the loop, if loop, if whatever that left is less than or equals to size, and array of that left should be if it is greater than a of max. That is, for example, the value, for example, if you take 1, if the left value it is greater than 20, means we need to swap, right? So I will take that max equals to left, that indexes. Then similarly for the right also we will do. Then at last we will check if index not equals to max. If it is changed, it's okay. If it is not if it is changed, means we need to swap, like it will be like first the max. uh, so first I will take max equals to index, right? So starting, for example, I'm taking from 3. So max will be 3. Max will be 3. And also here we have indexes, right? So the left will be 3 3 2 3 6 plus it will be 7 and 8. But in the if case will fails here. So the index will be same one, so it won't run, it will fail. But after that, if we go after 3, we will go for 2, right? So when we go for 2, the left is 5, right is 6. Then here 60 is greater than 20, right? Also 50 also greater than 20. So we will simply swap 60 and 20. That function, swapping function, we will do here. Also we will again heapify it. So I will write this code in editor. So you can simply observe the code here. So first I will take int array. I'll take 10. 20, 40, 30, 80, 60, some values. Then uh, then I will take one print function to print the values. That is public static void, public static void print int array, and that int size will pass, right? So for int I equals to 0 to I is less than size I plus plus, then uh, then simply array of I plus is, so it will be like public static, wait, array. I will run the program. Print I will pass array comma, and size is array dot length. So we have print the values now. This array I will build heap, that heap. So I will take first uh, build heap, public static void build heap, and here I will take int array, then I will take int size, then I will take that left and right nodes, uh, size by 2. So for in already we have taken int value, size is greater than or equals to 0, I minus minus, and I will take here a heapify function, heapify arr, and I will take a size. Now I will write the logic for heapify. I'll take for that public static void, and heapify I will pass the arguments int array comma int index comma int size. Then I will take the code how to heapify, that we will find here. I'm taking max heap, so 2 into I index plus 1, and int right is equal to left plus 1. Now I will take if the parent is less, means we need to swap, right? The a child is greater than parent, means that is if left, for example, and first of all, if left is equal less than or equal to size, and array of left is greater than array of max Means we will take that max equals to left like that, and same. uh, get to that. Before that I will take into max equals to index. Same code I will take for the right. For the right side I will take if right is an array of right is greater than means, then I will take the max value is right. So if there is a change in max value, then we will take that while condition, right? While index not is equal to max, then I will swap into temp equal to array of max, and array of max is equal to array of index, and array of index is equal to temp. And also I will do heapify again here. uh, Heapify that array. It will be long process to check to dry run the complete code. So please do dry run the code, and you can understand easily, like this is the code for you can pause the video and check for code for building build heap and heapify. So we will just now will do now that process, that is we'll call that function build heap, and I will take array dot uh, length minus one, because last index will take. So, and that's it. Then I will then I will after that I will also print it to show. uh, After running the code, we have got like this. You can pause the video and check the code logic here. This is. So now I will run this. So for given the array, I'm getting like this. So okay, and I understood this one is I have done all these steps, right? I have taken the array, then I have done build heap, then heapify, and I have swapped these ones. So here, so even the result we have got like this, like if check here the values are if you got here 830, this one 10 20 40, we have got 8 30 60 10. So that means the given array values are 10 20 40 30 80 60 50, right? So so we got those values like after heapify we got 80 30 60 10 20 40 50. That means how can I write? This is 80, this is 30, this is 60, then again it is 10, it is 20, it is 40, it is 50. So this is the max heap. We have built it. uh, for the given array like this, we have modified like this. Now if you want to, so now we will talk about some operations here. If you want to delete the operation means, how can you do? Simply you can swap the array of 0 with uh, array of size, right? You can swap with the 0 index and size 6. So this 0 index and this 6 index you can simply swap, and you can then you can reduce the size. Then you will you can again heapify the uh, difference, that array and 0 and size. So the 50 will comes here, the 80 will comes here, and we will reduce the size. So the maximum element we can delete here. This is a function for deleting delete max element. Now we will discuss one important problem. How can we solve it using uh, heap data structure? For example, for the given data, if we want to find, we have data 10, 20, 40, 30, 80, 60, 50, right? We have, for this, I have to find kth smallest number. That is here. What is the first smallest number? That is 10. So what is the second smallest number? This is 20. What is the third smallest number? That is 30. So we can use normal sorting algorithms also, but here we can get less time complexity. So like that, if you want to find the third smallest number, that you can get directly as 30. So we will write the logic for this code now. We'll continue here itself before amplifying it. I will take that function static indicate smallest number. That is, I will take int array and int size, also int k. Now I will do build heap effect. Build heap. I will take array comma k minus 1. Then I will take now right. So I will take now for k I equals to k and I less than or equals to size. If an array of I is less than array of 0, then we will simply take that array of 0, array of I, then again heapify. The dry running of the code will take very long time. So simply do the dry run for the values. The logic remains same. So at last we will return that array of 0. So now I'll take here directly object dot its smallest number, that is I will pass array, and I will send array dot length minus 1, and see whatever the values you want you will get. For example, if you want first element, So that is 10, right? So we got 10. If you want second smallest element, so that is 20, right? So you got 20. If you want uh, fourth smallest element, so whatever the which smallest element you want, that number you can give here, and you can get that one. So uh, so you can pause the video and check for the codes. This is all about heap data structure.